So let me open the sixth plenary talk of JSALT 25. And it's my great pleasure to have Xavier Serra, a professor at the Department of Engineering at Universitat Pompeu Fabra. I'm sorry for my Spanish pronunciation, in Barcelona, where he founded and directs the Music Technology Group, or MTG. So Xavier has a master's from Florida State University and PhD from Stanford University. And he's recognized for his contributions to sound and music computing, and particularly in the analysis, description, and synthesis of musical signals, as well as some like trustworthy and ethical AI methodologies for the music. And we will hear about all that. So just to note that Xavier has a advanced grant from the European Research Council, ERC. This is a very valued European grant scheme for the comp music project that is unifying engineers and musicians in multicultural and interdisciplinary approaches. And he currently directs the UPF BMAT chair of artificial intelligence and music. And I think that's where I'm gonna stop. I pass it over to Xavier, and many thanks for being with us here.
Thank you very much. Okay, hello everyone. First of all, thank you very much, Honza, for the invitation. It's a pleasure to be here. Sincerely, I didn't know about this school and this workshop, and the learning about it. I think it's a great initiative, and I'm sure it's very fruitful for all of you to be here. My talk is not very much related to what you're all doing, but hopefully it might be interesting, and nowadays methodologically is very much aligned. We are all working with very similar approaches to analyze both speech, music, and many other type of signals. So I want to take this opportunity to give a little bit of an overview of what we are doing, but focusing specifically on this topic, on methodologies for music understanding and generation in the context of trustworthy AI. At the MTG, well, we are many people, and we work on quite a number of topics, quite a bit beyond what I will be presenting today, but clearly all the things I will be talking is the result of a lot of PhD work and projects and initiatives that many people are carrying out. So I want to first highlight some things of the MTG. So maybe if some of you have followed the area of MIR and our work, you might know some of them, but that will give you some of highlights of past work. Then, of course, like you all are working with LLMs and how to try to make sense of LLM methodologies and how we can take advantage of them in our work. So I will give you our current view of how do we see the usage of LLM in our work of music, mainly music understanding. And then in music particular, I think all the ethical, legal issues are, I think they're much more relevant than, for example, for speech. The main reason is because there is copyright, it's a cultural asset, music, and therefore it's bound with a number of legal, regulatory, and ethical issues that we have to pay attention to. So I will mention some of that. And finally, I want to talk about some specific projects that exemplify our current work on this idea between LLMs and music and what do we do. Okay, so let's do a little bit of history. Well, in my PhD, I worked on synthesis of musical instruments. But then the main application that I work on when I work at Yamaha, and then I started the group in Barcelona, was the singing voice. And out of that work came the Vocaloid. It's a singing voice synthesizer. And Asian people, especially, of course, Japanese, this was done in collaboration with Yamaha. I think they might recognize this. It's quite a relevant cultural icon in Japan. And it's, well, I don't have time to go around it, but it's quite interesting. And this was back in the early 2000s. We worked on it in the 90s, but then 2000s, that's when the first Vocaloid synthesizer came. And we have been continuing working on that for a long time.
I believe Karma's, a lot of its funding came from
Yamaha, of course. My supervisor was John Chowning and Julius Smith, and so because of that, our relationship with Yamaha was very strong. I joined Yamaha after finishing my PhD. They created a research center there, and yeah, clearly it's all that relationship that evolved from that. But in the late 90s, it became clear that in our field, we had a problem with data. Because of the kind of things that I will be talking about in music, it's not easy to get legally adequate data with which to do things, with creative work, analysis work. And in the late 1990s, that was when beginning of the 2000s, the field of MIR and the field of needing large collections of audio started to be relevant. So we started this initiative of free sound, which maybe a number of you know about it, because I would say it's basically nowadays the typical data set used in all audio LLMs. Because it's legally it's correct, it has Creative Commons, it has more than 700,000 sounds. But apart from the research, is really, it has built a community. There is more than 16 million users. We maintain that from the university. And there is a very active website that, of course, can be used for research, but it's very much used by artists, by composers, by sound artists. And, well, hopefully you might use it. And of course, we always try to update it, maintain it, and keep adding technology to support this framework. And that's a good test bed for us to try things out and exploit things in real life with real users. In parallel to that, also in the field of music, the same that in speech. At the beginning of MIR and the beginning of machine learning, was clear that we needed very efficient algorithms with a lot of signal processing to be able to extract features with which to do then machine learning efficiently, and we were interested in industrial applications, so we started developing a library called Essentia, in which we tried to compile all the algorithms that PhD students, researchers at the group were doing, and we created a company based on that, BMAT, which is quite successful in the area of fingerprinting and identifying copyright material. And it has been evolving through the years. It started with DSP algorithms, and so there is a lot of features to do all kinds of audio-related analysis. But of course, in the last few years, the main focus has been on machine learning, and there is quite a lot of algorithms. Well, there are classes of models with many versions of it, mainly using TensorFlow, quite efficient. And not only the models themselves, but we are interested, of course, in making it useful for research and for industrial applications. So we have been maintaining and developing easy interfaces to access that, both like with JavaScript, so that you can run these models or these algorithms on the web, or with an API so that you can do this analysis from our servers. And we have been licensing, and which it's open source, but at the same time, it's also can be licensed to companies, and so there are many companies that use this as their backbone for many music analysis related topics. The project that was mentioned about this ERC project, well, yeah, I cannot spend much time on all these things, but let me mention because I think it's quite relevant. I have quite a long history of working in these topics, and 15 years ago, I was invited to India, to IIT Bombay, to give a talk on all these MIR music analysis and how wonderful all these techniques that we have can support all the music and can develop recommender systems and things that can support the industry. And I realized that a lot of the technologies that we had, or let's say most of them, would not work for Indian music, would not work for the tradition of the classical traditions of India, both Carnatic and Hindustani. So, and of course, that was a very interesting challenge. And so I came back and I put together this project and apply, and has been a very, very fulfilling experience to try to focus on certain music traditions. So I extended to the two classical traditions in India, and Beijing opera, Arab Andalusian music, and Makam music from Turkey, trying to see how can we develop technologies that are cultural specific, that really focus on the specificities of a particular music tradition. And of course, a major aim for that has been to build data sets, to build signal processing, to build machine learning pipelines that can solve particular tasks that are needed to listen, to visualize, to recommend, to teach these type of music traditions. And the major contributions, I think, have been at the level of data sets. So now, out of this work, there has been good collaborations with people in all these countries, mainly in India. It has been the most successful one, and the most successful one has been in the Carnatic, the south of India. And there are very nice data sets that can be used openly and that can be used to tackle quite a number of very interesting tasks. Okay, so these are some highlights of things we do. Let me go now, and I'm sure this will resonate with all of you. Okay, we have to understand how we bring all the LLM world in our music work. Okay, so, and by music work, typically music understanding for me is a good goal, good sort of concept that embraces a lot of things we want to do. So we want to develop technologies that can help us understand music. And by understanding music, I mean to the finer detail of music, not just trying to classify genre, but trying to analyze chords, melodies, trying to help someone practice a musical instrument, et cetera, et cetera. So the kind of framework that it's not completely done, but this is, let's say this would be a good view of what a lot of the new projects we work on are trying to fit in. Okay, so the idea, of course, is that we need data, and I guess as you all know, in music in particular, the availability of data is clearly the biggest bottleneck. And by data, typically people think, okay, we just need audio, we just need a lot of YouTube music, and that will do the work. It doesn't. I mean, when we want to really do music understanding at a very fine level, in fact, the single most important data source would be the symbolic music data. Symbolic music is the type of music that would really correspond to text in speech processing. So a transcription of a music that captures a lot of the complexity of a musical piece. Okay, and that's very difficult to get, very difficult. all the publishers publish in printed as an image. So there is very little machine-readable symbolic data that can be available to do research. Of course, the option is to have sheet music in printed music, so images, and then try to do OMR so that you can then convert the image into a symbolic music. And then, of course, very importantly is all the text accompanying music, and that includes lyrics, commentaries of the music, metadata, you name it. There's a lot of classes of text and metadata that can be processed.
What's the state of the art in converting sheet music images into symbolic music?
It's getting very good. Interestingly enough, not from the academia, from the industry, and therefore that means that there is no open source systems available for that. And they are normally work for niche areas. So for example, for piano, well-printed piano music works quite well. For multi-staff music scores and manuscripts, no, very, very badly. But for well-printed music in a very constrained use cases, it's pretty good. The same thing that transcription from audio to symbolic. Again, piano is an example that is the easiest one to do, and it works quite decently well. I mean, it has to be revised. So in fact, it's better the audio to symbolic than the sheet music to symbolic. Yeah. Okay, but then, okay, so this is important. And then, of course, we need to bring, we always use a pre-trained model, open model that might exist, like Llama or something like this. So the issue is, okay, how do we enhance an existing pre-trained LLM with all the music information? And I guess most of you are aware of that the typical thing is to basically fine-tune that and get some other type of data. So in this case, the audio data, text data, MIDI data, or scores, and you sort of integrate it into the model, and with some text instruction, you can sort of fine-tune the language model. You sort of do continuous pre-training of that so that it can learn about having some input, some of this music data, and being able to get some meaningful output. And that's where we are, and I'm going to talk about some projects that we are aiming for doing that. But then, of course, the important thing is what are the tasks that we want to work on? And I think that's quite different from speech in the sense that the relevant musical task and the ones that can be properly evaluated, well, there are many. Traditionally, classification has been a lot of our initial work on deep learning was to build classifiers to tagging or multi-tagging type of tasks. But there are many others, and for music understanding, again, transcription would be an important one, also to be able to get a symbolic representation of that, and any text or symbolic view of a piece of music that can help us understand, and out of that, be able to develop some other applications, so like semantic level type of applications, and description type of applications of a piece of music. And there's quite a number of tasks that we are working on. And again, if we are in the space of LLMs, the idea is to do it with text prompting type of input and text output as a way to get the analysis of that. So that's I think, our current view of what we should be working on, okay? So,
I think there's we have a question.
Okay, go ahead.
Separate the mic for the questions. So that
Go ahead.
no, it's for the
Thank you. For the middle part,
Yes.
so if I understand, if you have a language model, you can just train it based on the next token prediction or whatever you decide. But for this particular part, I'm not really understanding what would be the task. You have some training data where there would be some specific question and answer, or
Well, this is you can do some fine tuning with some music specific so that it can properly be able to evaluate this. But this is a very generic.
But what would be the task for that? You would like to.
Well, the task we always evaluate with these ones. So at the end, this is to create embeddings that you can do some very generic tasks, not very specific, so that is able to, you can put...
But maybe could you give one example of what would be the question?
Typically here, you do it with the simple classifiers, or you give it an audio and return the genre of a piece of music, or...
Okay, so you need some transcribed data for that.
Yes, yeah.
Thank you.
Yeah. But again, the goal, this typically is not enough, so you always have to fine-tune it quite a bit for particular tasks.
I have a question about the symbolic representation. So MIDI and the notation is very specific to Western music. How about everything else that is probably not like written? Do you have some clues, or are you developing or maybe like using some other type of symbolic representation for the Indian music and Chinese opera and I don't know,
Very good.
stuff?
Well, the truth is that many music traditions, because of the Western imperialism, have have adapted Western symbolic representations. Chinese is a special case because they had a symbolic representation long back, and so they have a symbolic representation. Turkish music, all Arab music, they basically took all the Western and they adapted to their own. Indian music is a very interesting case because when we started the project was, for me, the example that symbolic representation didn't make sense. It's an oral tradition, and the musicians are very much against any symbolic representation. So we started with that, trying to forget about symbolic representation and try to find some features of the pitch, of structure, that would be closer to the idea of this oral tradition. It has not worked for all these years, so we are now to symbolic representation and trying to find symbolic representations that are adequate. So we are doing our main effort now in Indian music is automatic transcription with some sort of symbolic representation that is not the Western one, but at least identifies the note symbols, identifies the qualities of the ornamentations that they have, et cetera, et cetera. So we are trying to do a symbolic analysis because otherwise it's impossible to do any semantic type of reasoning on top of music. Yeah. Okay, but as I said, ethics is at the core of many of these things and for many reasons. And let me go through the typical ethical principles that we have to pay attention to. And here is a list of them. Clearly the respect for creative integrity. So in music, again, we are dealing with pieces that have an author. They have a coherent concept behind that. You want to make sure that you maintain and respect that. You want to make sure that you credit the creators of all of that, and that so you can support that. You have to make sure to support cultural sensitivity. You cannot just have a kind of a unified symbolic representation for all of that. You cannot have a unified data set that captures everything and put it in a single basket. No? Also, being a cultural asset and education being a fundamental part, so you want to make sure that these type of technologies are supporting this cultural context, this educational context, they support this reality. Bias, of course, is a fundamental thing, but in music in particular is huge, so you want to make sure that at least you cannot of course, ignore, you cannot get rid of biases, but at least be aware of them and try to be explicit about what biases are you bringing in every type of situation. And then, of course, all the user interaction, user control, personalization, and ways that the human in the loop is well supported. Do you have a question?
Yeah, I have a question. So some of these ethical questions, I suppose I understand. So for example, if you said attribution and credit, I would take that to mean that if I'm going to take some bars or some things from somewhere and use it somewhere else, I shouldn't pretend that I came up with them, that I should attribute that this is from there and so on. I don't understand some things. In other words, I can't think of in what way I would violate them. So what would be an example of violating the creative integrity of some piece?
You're cutting a piece of music and reusing it. So many artists would be completely against sampling their music and taking it out of context and giving it another meaning.
Okay.
So the concept of an artwork that has an integrity and has a context and it has to be preserved. It's not a signal. It's much more than a signal.
Okay.
It's a signal with a whole cultural context, personal context, and we want to preserve that.
Okay.
Okay.
All right, and in case of human-machine collaboration, what kind of thing?
So again, I mean, this is of course mostly our view that music culture is a social phenomena. Mm-hmm. It's not a one-directional company building something for a final user. Okay. It's the result of a culture, of a society, of interaction. All the music in the past and currently is the result of this interaction. Mm-hmm. So you don't want to have closed type of things that creativity of the listeners, of other users cannot be part of that.
Okay. All right.
Okay? So this type of thing.
Yeah. No, okay, I agree. So what I'm thinking is that, like with a lot of other issues of understanding ethics, it helps to sort of see examples and say, this is a case where something was not done right. And I'm not asking you to go into them.
Correct, yes.
Think.
Yeah.
So the creative integrity makes me think like, imagine that if a piece of music was written to evoke some sense of accomplishment after having overcome some personal difficulties, and then I use it to show some video where some troops are destroying
something. This would be an example.
That's an example where it wasn't meant to be used in that.
You are taking it out of context to mean something that the original artist didn't want to.
Okay.
Yeah, right. Correct.
Okay, thanks. Yeah. All right, thank you.
Okay, and yes.
Are these things evolving? Because, new generations of musicians are being trained with many digital tools and they are using it all the more. So I can imagine what was unethical a few years ago is quite ethical now.
Exactly right. Or the opposite. The opposite, because simply by the fact of AI, that of having easy access to copy, remaster, reshuffle a piece of music, if it was done by a classical composer taking an inspiration of an earlier composer, that was okay, but now, because of a scale, then it's not ethically correct. So I don't know, I mean, there is a lot of issues that there. But anyway, of course, every country is trying to regulate this, and it's not easy. How do you regulate all these ethical principles? So we have the ethical principles that I believe nowadays it's very much a public debate, and I would say that everyone would agree with these ethical principles. The problem is how to implement them and how to make them, and then how to make sure that the research, the companies that are supplying and developing this ecosystem of technologies fulfill these ethical principles. And the AI Act, in Europe, there are a number of regulations that are impacting AI. The most recent one is the AI Act. the AI Act was passed this year, at the beginning of the year. So now it's a law, and it's being deployed with different in phases. The one that I want to just briefly talk about, so to put an example, because we have been involved in, is Article 50 of the AI Act, in which Article 50 says that providers of AI systems, so that means providers of a AI generative model that is integrated into any device, has certain responsibilities. It's very important that the final user is aware that he's interacting with an AI system, okay? And then explicitly, it talks about this generation of audio, image, video, or text, that any content that is generated has to be marked as AI generated. And it has to comply to certain criteria to make sure that this marking is correct, okay? That's a big problem. So the lawyers from the EU came up with this writing, and then now they are asking researchers like us to figure out how to implement that, how to they have to come up with some guidelines that will require the companies to follow. So we have been working, we still is not finished, a technical report on trying to figure out what technologies are adequate or not for marking AI content. And this is a summary of the table we have. I don't have time, but clearly there are 4 types of technologies that we can use for marking any audio content. So we are working on the audio content part. So there is metadata and with encryption, so you can encrypt some metadata in a header of a file and describe that that's AI generated. You can watermark, so with a sort of a hidden information in the actual signal. You can use fingerprinting as a way to codify a piece of music and then be able to identify it. And then now there is a lot of activity on model identification, so AI models that are able to identify that a piece of music has been generated by a particular system, being Suno, Udio, or any generative system, okay? So we try to go through these technologies, define some criteria with which to evaluate them, and so we are now in an open debate or discussion with companies. We've been talking with many companies to try to see what is feasible, what is not, and if it's possible to try to come up with some clear guidelines of what to go about. As you see from this table, there is a lot of red crosses. So that means that there is no solution, there is no perfect solution for this, and the EU has a problem. And of course, apart from that, there is a lot of lobbying and debate from all these large corporations to try to minimize the impact of this type of regulation into their business model. But anyway, that's an interesting area. But hopefully, well, at the beginning of next year, this has to be enforced, and all AI companies that want to deploy systems that generates AI content in Europe will have to comply with that. We'll see what happens. Okay, but these ethical principles, they result into technical problems and research problems that have to be carried out. And these are some of the topics that we believe are fundamental. So these are research topics or topics that impact directly our work that I believe should be further developed in order to comply with these ethical principles that I talked about. And again, I'm gonna, with the projects I'm gonna be talking about, cover some of that, so we will talk about that. But of course, open science for me is a fundamental framework that is fundamental for supporting ethical ideas. The idea of creating data sets, how you do it, the idea of how to develop analysis techniques that take into account this cultural diversity, the concept of developing technologies to recognize and the author or the ownership of a particular content, all the topics related to mitigating and recognizing biases, all the issues of explainable models and how to make sure that what a model is learning, you can understand what is being learned, and then developing interfaces, ways that you allow the model to not be a black box, but that can interact with users, and that there are platforms to support that. So let me talk about some of the things we have been doing along these lines that can give you an examples of that. Well, the first is the idea of open science, of course, is very much related to the idea of open models. No? I mean, we want to be able to have AI models that are transparent, that are explainable, that are shared. I just was reading in the paper, we believe, okay, we say Llama and we say, okay, Llama is an open model. It's not an open model, Llama, okay? And the AI Act explicitly mentions some considerations of open models, not very detailed, but clearly there is this idea that open models should have some legislation that is different from the industrial closed models. So the idea from an European point of view, we should encourage open models because that's a way to support small companies, to support research, and to support innovation in a broad manner. But there is no definition of what an open model is. Of course, we all come from the idea of open source. Open source, I think, is quite clear, more or less. But as you apply that to models, it's much more complicated, okay? So we did a paper that is being presented this year at ISMIR, in which we defined, well, we took some criteria for open models that have been published and tried to apply it to audio LLMs and music LLMs and see if they would fulfill those criteria, okay? So these are the different models that we analyze. There is some essential criteria that we define, like of course, the availability of the source code, availability of the training data, the availability of the weights, the documentation, publication, et cetera, et cetera. And as you can see, there is not a single model that fulfills those requirements, not a single one, not even the ones coming from academia. In fact, we are far from that. Typically, the one that only one system complies is the idea of the availability of the training data. Only Stable Audio open, because they use free sound. There is the data is open, and they also use Free Music Archive, so it's open. But all the others, they don't share or they cannot share the training data in some way or another. Typically, the documentation, the publication, and it's might be pretty good, so documenting the code, but there are many criteria that are not fulfilled, okay? So the idea is that I think, first of all, there has to be a definition, a standardized definition of what an open model is, and then we should try to figure out. And so, as I said, no, the training procedure explanation is the most open one, while the training data is the worst one on that. And the idea of this is that we created a website, and the idea is that people can keep adding models, explaining them, and so this is a collaborative initiative to maintain this information. Okay. Another issue that is related to what the presentation we had here yesterday about a notation of LLMs. So it's clear that LLMs and audio LLMs are pretty bad at music for many reasons. So again, we wanted to formalize this concept, see how can we develop a framework to properly evaluate music understanding. And so there is this paper that was published last year, Mucho Music, in which we try to define a framework, a benchmark for evaluating the music understanding of LLMs. So what we did was to do a multiple choice set of questions. So we compiled 1,187 multiple choice, humanly validated. This is part of another project in which we ask people to describe music. But, well, you can read the article. It's quite detailed of how we did that, what categories, how we organize all the answers to make sure that it was covering all the different aspects. So here are the different aspects that we explicitly are measuring. No? For example, things that are very much music theory, like the harmony, analyzing melody, analyzing the texture, the meter, rhythm, performance, and both more descriptive type of analysis and more reasoning type of things that if the LLM is able to relate concepts together. And we compared, and the idea is that, well, to compare only, of course, trying the open sort of models that we could evaluate properly. Three of them are really music-specific models. Some are more generic audio LLM. I'm sorry we didn't include Flamingo, but and here it looks about, the result is pretty bad. I mean, they are all below 50% of accuracy, where 25% is random. And for some of these more descriptive things, it's close to 50, but more the reasoning aspects is below 40. Most of them are below 40. They are not doing that well. Well, anyway, I think it's a good framework to evaluate models. It's all open, and you might be interested in looking at that. Going back to, well, more technical things, in fact, the first PhD thesis we did fully dedicated to deep learning was this one by Jordi Pons in 2019, in which, like most of us, started from the CNNs coming from image and square convolutional filters, and it was clear that that would not work for music, in the sense that music has both vertical concepts like harmony, and it has horizontal concepts like melody, and they require different resolutions. So in the time-frequency plane, you cannot use a single short-time Fourier transform with a single resolution to get both time and frequency criteria out of that. So in Jordi Pons' thesis, he came with this music CNN, which is the idea of having different filters with temporal and frequency resolutions integrated in a way that you can get both time and frequency analysis. And it got some good results. But this is a little bit old, but it was quite useful. Another important type of idea that we are still very much working on is the idea of interpretability of the networks. And this is the idea of, it's a paper that was published in 2020. This was for sound, so this was presented in decays. And the idea of this is that, that we want to be able to listen to what is learning. No? And this is a classification task. So when you ask this, any classification network and to classify the sounds, environmental sounds or musical instruments, you would like to understand, okay, but what has it learned about that instrument or about that class of sounds? So with this idea of, this comes from image, this has been done in image, so we adapted that to audio, and the idea is that there is a layer that is added that learns these prototypes per class. So every class prototype is learned, and is learned in a manner, we use sort of a spectral representation that can be both encoded and then decoded, so then you can listen to the latent space embeddings through the decoder. So you can have these prototypes, and you can decode them and hear a representative sound that reflects that particular class. And of course, the core part of that is how to find a similarity measure within the latent space that is perceptually relevant. So it's a frequency-dependent similarity measure, so that hopefully when it learns the prototypes and when it does the classification, it captures the frequency-dependent perceptual characteristics, so that you can understand that classification. And of course, the idea is that it's not to beat existing classifiers, but we were able to get state-of-the-art classifications while making sure that this prototype learning is in place. And it's not that much more expensive to do that than to do with a normal classifier. Okay. Anyway, so we should be finishing. So, and let me finish with another paper, which is the one that maybe is most related to this idea of our current goal of building an LLM framework and building all the pieces. So in order to build all the pieces, so we have started from the audio. Again, we have many models that have been trained with audio-text pairs, and we especially work on classification techniques, and that has worked. But now the idea is, if we want to scale it to all this LLM framework, we need to improve all the creation of the foundational model and how to fine-tune an LLM with the different modalities that we use. So this is our first attempt to build the encoder for audio, self-supervised, so that then we can integrate it into the LLM. So we finally, for a couple of years, we have access to big computing infrastructure, which is not easy in academia. So there is this supercomputing center in Barcelona, the BSC, and we have access to that. We can apply for a project and have access to that. So we have been able to train a number of our models there. So we are, it's a conformer XL model architecture, so that's very much used in speech, so that's the same one, but is used in an unsupervised or self-supervised manner. So we use music from YouTube, and that's the biggest problem. It's impossible to be able to do anything with non-copyrighted material, but of course we can do that. In academia, we have the exception to be able to use copyright material if it's non-commercial. And still, even though this is not even a generating system. So now, for me, there is an obsession of everyone that's thinking that we are doing things illegally, and then that prevents many of us to do research because we are afraid that some corporation will come after us, or some record label or whatever will tell us that we are not, which they do. But we should reply that is not true, that for doing research, we can perfectly do this type of thing. And on top of that, this is not for generating audio, it's just for getting embeddings out of the audio. Of course, they could be used for generation, but it's not the intended. So the illegal part is the generation, not the creation of the embedding. So anyway, one of the big things is that to get good data, and to get a lot of data, of course, you can crawl YouTube and get all the music there, but that's typically is not good in the sense that there is a lot of bad music, there is a lot of bias towards certain music styles, et cetera, et cetera. So we have been working a lot for many years with Discogs. Discogs is a collaborative website that organizes records and specifies a lot of metadata, typically genre, in a fine-grained manner. So that's a good thing to try to just choose music from YouTube that covers and is quite diverse enough so that we are able to cover all musical styles and we are not biasing any music with respect to another one. So we chose these 330,000 hours of music, but using Discogs as guiding to select those, even though we don't use any of the Discogs metadata because that's going to be another task that we will do, that we are now doing to do the training on the pair data. And for us, we have been mainly working on classification, so we typically were taking a frame rate that was quite big. So now with this, we are starting to get frame rates that are the order of 30, no, this is, where is it? Right, the 20 hertz, so 25 frames per second. So with that, we can start doing interesting tasks, and it's getting closer to generative type task, okay? So, and what we did was to try a lot of things, try a lot of different input representations, target representations. So this is unsupervised. So what we are doing is we are creating these labels, but the labels are code words in the latent space. So you quantize, and so we are trying then to map any audio into this finite set of labels. So these are the number of labels we use. Oh no, they are not here. Well, we use different number of labels, and also we try, well, these are millions of parameters, so it's 580 million parameters, so that's, for us, that's quite a big bit for what we are doing. And again, we are trying with different configurations, with different features, with different codebook lengths, different codebook lengths, different the different bases, and we compared with our previous kind of model. MAEST was a model that meant to be used for classification, that had a rate, what is that? Oh no, okay, we extended, so that of course it was much smaller, and it was trained with classification, so the input was MEL frequency spectra, and the target was genre labels. And these are two open models that we could reproduce, we could adapt for our tasks, so that we use their weights, but then we were able to use them in the downstream task, okay? So the idea is these are all generating embeddings. with different characteristics and with different representations. And then what we are doing is evaluating in different musical tasks that we have been working on, and we have state-of-the-art, or we have existing models that work. So again, the typical one that we have been working on for many is tagging. But for example, now we have one on difficulty analysis of how difficult is a musical piece to be played. Pitch analysis, so that's a quite fine-grained need for representation. Identifying chords, identifying the beat, and identifying the structure, okay? And, well, you don't see the bold from the non-bold, but you see clearly that there is not perfect representation for all the tasks. So, for example, for tagging, clearly, since our model, MAEST, was trained with tagging, is the one that performs the best, and it has a big batch size. And but for all the others, each one has a different characteristics. So now the idea is to how can we have a single model that is good at all of it? Because again, in music, there is so many parameters, so many criteria, and there is time resolution, frequency resolution, many different things that might require different trade-offs, different representations. And so that's where we are here, and of course there is much more. We are trying to do the same thing for symbolic data. We're trying to do the same thing with images, and then trying to then incorporate that into existing LLMs. Yes?
Yeah, I'm not very familiar with these tasks, so I'm trying to figure out what these numbers mean.
Okay.
So when it comes to tagging,
yes?
because you say MAP, I'm guessing that it's a binary question, is it this or not this, and you're measuring...
Well, it's a collection of tags. I mean, these are very many tags. I mean, I don't know exactly which one was this one, but these are... hundreds of tags.
Okay, so it's like a class. Well,
yes, it's a classification. It's a pure classification task.
Okay, I'm then trying to figure out why you use map as your metric in the sense that.
Good question. I didn't do this, so I don't know.
Okay. Yeah. Then when it comes to difficulty, I can imagine there's a mean squared error. So is the difficulty on a scale of 1 to 10, 1 to 5, because it would change what 1.6 might mean, right?
Well, this was done with the experts. So
yeah.
this was, we had a kind of a ground truth base with experts that we train it on, because we have another model for difficulty, and so we train it with, and we gave a 1 to 10 measure.
Okay. So it's within 1.5 or 2.
Okay. Something like that, yes.
Then again, I can understand chords, just accuracy, because either you get the chord or you don't.
Right.
How is pitch measured? Is it like the exact frequency, or do you say within some tolerance?
With some, you give a.
Okay, so within some tolerance, and so 94% of the time it's within tolerance.
Yeah.
And I don't know what structure is. Could you say a bit more?
Structure is whether it so we have data sets, especially in pop music, that it has the verse and all these different sections, and so whether it's able to identify these different sections of a piece of music accurately.
Okay, all right.
Yeah.
Okay, all right, thank you. Yeah, just trying to get a sense of what these are.
Correct.
And when it comes to things like chords, right, okay, so the best model has 75% accuracy. But if I were playing a sequence of chords, right, some sequences will just sound ugly. So do you use any sequential...
These don't make any sense unless you understand the data set that it is compared with doesn't make much sense. I mean, absolutely, this doesn't mean that these are very good. Chord is such a complex concept. And typically all the data sets for chords are very simple chords. They don't include jazz, sophisticated chords. They typically include very simple triads. So the 12 major and minor chords of pop music.
Got it.
Not of classical music, not of...
So this would be like from my Guitar 101 class or something like that?
Yeah. Excellent. Okay, and I guess with that, we can thank you very much. I finish here, and we can have some questions. Thank you. Any question? Yes, one there. And by the way, Don't ask me very technical questions because I am not the expert of this, but I can put you in contact with whoever was involved in that.
Thank you so much. I'm hesitating now to asking question.
Okay.
You propose a principle, ethical principle slide with all the criteria. Now I'm wondering if there is any study or you have, you know any study that try to simulate, to measure this aspect in a mathematical way.
Which, the criteria for what?
The slide that you have, ethical principle that you proposed, the ethical consideration that you had, one slide that you had with different aspects.
Of the LLM understanding? No, the ethical principles. Oh, the ethical principles.
Yeah.
Okay. This, the research part of the, or
No, the previous one.
The previous one, okay. So that's, yes. Sorry. The ethical principles. Yes.
Yeah, this one, yeah. So, in continue of the question of Sanjeev, I wanted to know if, for example, we can measure how respectful are our model toward the creative integrity. So, in that sense, we can define an objective function, then train the model to be as respectful as possible to the creative integrity and can be applied to all other metrics. So is there any try to somehow formulate in a mathematical way to calculate the bias awareness, the user or cultural sensitivity or other aspect?
I don't think so. I mean, and they are all definitely not objective measures because, again, the idea precisely behind all of these is that it's very context dependent, cultural dependent, personally dependent, subjective. So the important thing is to have some sort of criteria with which to evaluate, but you will never have a metric that will give you whether that's sufficient or not. But at least to have some, the same thing that the idea of openness of a model. Openness of a model cannot be measured with a number, but at least have some criteria. Some are descriptive, some are more analytical, but many of them are descriptive things that you can talk about.
Okay, so if I try to imagine, so some artists try to claim that he's or she is violated by some of these aspects in the court. Finally, court make a decision, a judge make a decision. So I try to put this judge as a machine.
No, but let's distinguish ethics and regulation or ethics and law. We're talking about ethics. We're not talking about law. Now the problem of the lawyers and the judges and the European Commission is to identify which things can be formalized and converted into law. And this is why the AI Act is so simplistic and only covers very few things, because those are the only ones that, that a judge could try to determine. These other principles, these are cultural principles, ethical principles, that, I mean, they cannot, so a judge will never go into this. So for me, there is an interesting discussion at the community and the level in terms of should everything be sort of have a law and have to be able to be determined yes or no, you are infringing certain things, or we should try to develop some shared understanding, some shared principles that everyone, of course, interprets in their own ways, but at least are principles that we believe in and that we are promoting. They don't have to be written in stone, developed into law to be implemented, because it's impossible, and we're gonna do harm to each other because every context is very different. So I think we tried, and as scientists, we want to have this very clear formulation of things, and as soon as you go into things like music, culture, I don't think you can do that.
So to wrap up, having ethical AI is not possible in your sense?
No. Well, ethical principles is possible, but to define what an ethical AI is, it's not possible.
Okay. Yeah, I understand your point. Thank you.
Yeah.
Hello, Xavier. I will ask you, because we are working in large audio language models. We are from the AUGE team. And the last trend of these kind of models, like in the past, it used to be that people used to have some kind of encoders, different like for speech, other encoder for music, and then different one for sound. And I could say that the recent trend is just to use a single one encoder for all three, like music, speech, and sound. Would you say that this will provide us enough representation for like answering questions about music or speech?
Well, the problem related with that is that it would be great, but for example, we were able to do the 300,000 hour audio. It's impossible to get 300,000 audio with paired data. So with audio, we can get up to 300,000 songs, well-balanced, well-distributed, all of genres. If we now want to also include metadata, that's impossible. So the one we're doing now that we have descriptions for all of these, maybe it will go down to 150,000. The ones for which we have scores, maybe it's only 20,000. So for us now it's best to have these kind of tokens that capture audio concepts isolated, the ones that capture symbolic content isolated, and then do this alignment and this sort of figuring out how to merge it into the LLM. Because there is no data, it's impossible. So the audio, for me, it's amazing, pure audio, well, that's quite a lot if we have a lot of audio. And we have a lot of audio, but it's impossible to get all the other paired data.
So your guess is that if we have enough data, then we can just train a single encoder of all of the information?
Yeah.
Okay.
Yeah.
Thank you.
So this is the context in which this Lion guy's work is quite interesting. For example, he has 12 million open sort of songs in a new data set, Lion Disco.
Right.
And plus he has so many different, he has a project to create 1 billion pairs of music and audio and sound snippets with emotion, right, and so on. So these problems you mentioned are very real, lack of data for training and so on, but there are people like that who are there.
Correct. But I heard the Lion talk, and basically he was saying, okay, this is very hard.
Yeah.
So let's generate it from the symbolic data.
Yes.
That's bad.
Yeah.
It's like getting a speech text paired, all generated, the audio synthesized with it. Doesn't add any information.
Yes, of course. But I'm saying the data problem can be tackled. Of course, we as academics have to be involved.
Yes.
And some of his data is bad, but not all.
No. But the problem is that in the area of music, for example, this is in the hands of all the publishers. And it's not something that you can crawl the web for. So what you get in the web, and that's what Lion is getting, the MuseScore, and this is user-generated. So we are now wanting to really get music quality. So we want to do music understanding at the level that a music student of an expert, or at least a music student. Right now, all these LLMs, they do music understanding at the level of a 4-year-old kid. So if you want to do, that's you need good data, and that's tough.
So I wanted to ask about this like European Act obligating everyone to mark the AI-generated content. This is a very nice idea, but it expects that there is either purely human-generated content and, on the other side, purely AI-generated content. But nowadays, I think you have many cases when the AI models are used as an instrument, like instead of playing my clarinet, I will take a model and I will be playing for a week with the prompts or mixing or anything, and I will get an output. Is it AI-generated content? Like, should I define it probabilistically, like it's like 7% AI and 93% Honza, or what is your, well, probably not legislators' opinion because they have no idea, but your opinion on this?
Yeah, okay. Sincerely, all of this comes from the industry. I mean, if you are really thinking of the music and the musicians, for me, this is not that relevant. But there is an industry that has, there is a lot of economical interest behind this. Nowadays, Spotify, Deezer, they get a big percentage of their music that comes in AI generated. And because of that, they are losing a lot of money. And all the author societies are losing a lot of money, and all these big shots musicians that make money with this, they're losing a lot of money. That's the context. So the context is to make sure for the music industry and the interests and the lobbies that are behind that, that these particular AI generated that is spamming all these distribution systems, they are losing money. They don't care about the musician that does that. So in fact, that's not an issue. So the main issue, sincerely, is that current record labels, current distributors, they want to identify when something is generated by Suno. That's it. And by Udio. That's it. Because that has a lot of economical value. These nuanced things are not on the table, and it's impossible. And it's related to these ethical and legal things. I don't think there has to be converted into legal frameworks. If everything has to be regulated in this way, I mean, what is creativity? Are you using 20% of AI generated, 10? Are you using a program that helps you? I mean, okay, I don't think that's, sincerely, I don't think that's an interesting discussion for the community. Yeah.
I had a question, if you go back to the Omar RQ slide about Discogs and things like that. So I have sort of two questions, essentially. One has to do with this work itself, namely, I was looking at the Discogs website, and you say in the paper, the Omar RQ paper says that the labels that they provide, the metadata, it's CC0 BY license, which is quite generous, but does have the BY part, namely to acknowledge the originators.
No.
Right? So.
But this is, we're only using it.
No, I know. So that's the question.
Yeah.
So if you use their metadata to choose the audio, so you're
right.
making sure you have a balanced collection of things, right?
Yeah.
And then you use only the audio for pre-training. Have you or have you not used their metadata? And do you then need to...
but you say CC0, no? The metadata.
No, but it does say BY. So basically...
BY, yeah, okay.
So how do you acknowledge...
That's why we say it.
No, I know, but so now this pre-trained model has been built. If somebody takes your model and builds an app, do they have to acknowledge Discogs?
It's their problem. I mean, we do our part, which is to acknowledge where we got the things.
Yeah.
So we are transparent, and this is the main thing of AI Act, is the transparency. We are transparent. We're doing academic things.
I appreciate that. That's why I was asking what happens to the model.
The problem is, I mean, and we are training with the YouTube audio.
Right.
So that's a bigger part.
Actually, that is also a bigger part.
That's biggest.
Yeah. But what I'm thinking is that the YouTube audio has one kind of issue where the owners own the copyright to it. This is a different kind of issue because this is the value they added. They actually specifically did the hard work, right? And then the other question I had was, so I think you answered my question.
Yeah.
The other question I had was, we've been working with these models like Audio Flamingo and this and that. How straightforward was it to scrape that data? What I'm wondering is whether these large models are already corrupted in the sense that they've already used all this labeled data. So when I ask my Audio Flamingo 3 what kind of genre it is or whatever, it's no longer doing a zero-shot pass. That it had actually seen thousands of labeled examples of everything. Do you have a sense for how easy it was to scrape it?
It was to scrape? No. It has. Okay. We have been doing that for a few years.
Okay.
So we keep extending it.
Okay.
So this is our in-house kind of data set that we have been scraping YouTube with this, and as we have been updating it with the Discogs keeps being improved also because so we keep updating it. So I don't know when was the last update of this, but this is not something of the last few months. This is something of a few years working on these slowly scrap.
Maybe this is just my remark to Ramani and the team. We should be careful about data contamination. These problems may have seen a lot of the data that we work with.
I would like to ask about the authorship. So far, if I understand that if I would compose some music, then nobody cares of what music I have heard during my life.
Right.
And if somebody would say that I copied something, it's only based on the similarity. So maybe I've never heard that part of piece of music, but I have maybe composed something that is very similar to that. Yeah. Today, if you think about the AI, people would usually say, but was it used as a part of the training data? If it was, then maybe we should say that it's similar. So this is like a different mentality, and I don't think it's really fair for the AI to do that, because the human also, that was the composer, also used that kind of music. Maybe he was aware of that, he was not aware of that, and maybe we could distinguish between that. But there is a quite difference between what we say that how it was inspired, maybe. So do you think that this gap will somehow, maybe in the future, be removed, and that we will no longer take care of what data it was used? Maybe then in future we will be able to use everything for the AI, and then only say that the authorship is based on the real similarity, not based on what distribution it was used to train.
Okay, I think that's a very fundamental question. Of course, this is the argument that Suno or Udio are using to defend themselves in front of the record labels. Let me answer something else completely different. Yesterday in dinner, we were talking about the salaries of people working in these companies. They are 8-figure numbers. The salary that the composer makes, they are 1- or 2-figure numbers. Okay? So there is an ethical issue here in which we have a technology that is based on the knowledge of all these people, and they're barely surviving. And thanks to them, there are people that are having a salary of millions of euros. For me, that's the ethical thing, that this cannot be. For the first time, we have a technology that requires everyone, and this everyone is barely surviving. And there is a few people that are getting millionaires. That cannot be. We cannot build a society based on this inequality, independently of anything else. I think that's, so we have to find a way. It can be many different ways. I don't know how, but that we can support an egalitarian society, that people that add value, and a musician adds value, and adds value to these people, that they cannot, they should make a living out of that. No? I mean, it's unbelievable. It's just, it's for the first time, I mean, it's clear that all these companies, the main source of value is the data. And this data, they get it barely for free or close to free. Well, they're now starting paying for the record labels, and the record labels, of course, they're going to do the same thing that Spotify. They will be able to acquire, and they will be able to maintain their business model. The record labels is not the problem. But this is a tiny percentage of the music that these models are trained on. And all the independent labels, all the independent musicians that also, they are in YouTube and they're going to be used for training, they get nothing. Yeah.
And this problem is there across AI.
Yes. But in other areas, maybe speech is, let's say, okay, it's not a cultural asset that people make a living out of talking, but, or, well, not that many.
No, but you know, you are a customer service representative, you have a job, you talk to someone who has a problem and you solve their problem, and now the AI will take your job and solve and do it.
Yes.
And so on. So there is going to be a huge change, and in some sense it's inevitable. So the question perhaps we should think about is how do we change the reward models of society? Because the whole pricing model which is there is a quasi-equilibrium which developed over a couple of centuries. And this appearance of AI changes this whole economics completely. And in some sense, the genie is out of the bottle, so you cannot sort of shove it back into the bottle. So you have to now think about what sort of equilibrium will we reach, which is on the one hand fair to the humans, but also perhaps lives with this inevitable change. Because if Europe just keeps regulating, it will develop elsewhere or wherever else. So anyway, that's just...
Yeah. Very good. Anything else? But for me, this, which is a fundamental discussion, is something that we as researchers have to put it on the table and in first person. I mean, try to see what are we doing to, we say, okay, we are only doing research, and okay, I have the research exception, like I said, and we can do it, and it's okay. But this helps, promotes given economical and business models, and that's something that we have to.
Okay, with this, I would like to thank Xavier again.
Thank you.
And just a pre-announcement, on Thursday we will have the last plenary talk by Jordan Boyd-Graver, I'm sorry, forgot the first name. So this Thursday, 11 a.m. here. Okay, have a good lunch.